So far, I've done 2 prior videos regarding the Wayland multi-window app situation. If you've not seen those videos, go and watch them. But the TLDR is on Wayland, there is no generic way for applications to choose where they're going to be placed. Some compositors may have the feature, but it's not something you can rely on being there. Now, this is generally not a problem. But there are applications that make use of these multi-window layouts. So instead of having a bunch of components in one major window, something like the multi-window mode of GIMP. A lot of scientific applications, and applications like MPV, which provide a geometry option. All of this is being spearheaded by a PhD student by the name of Matthias Klump, someone who is being directly affected by this problem, who normally wouldn't be doing Wayland things. He'd be too busy working on other things like AppStream, PackageKit, and doing various things over on the Debian side. But someone's got to get this problem fixed, and it might as well be him. His very first attempt was add ext placement protocol for output relative window placement preferences, which sounds really fancy, but all it means is an application can choose the monitor it wants to spawn on and the coordinates of where it wants to spawn. Pretty much what you can do on X11, Windows, macOS, and pretty much anything else out there that's designed sensibly. Now, this got some support from some KDE devs and some Budgie devs, but ultimately, it got knacked by Western and then later GNOME. So it, at least at this stage, can't be an official protocol, but it can exist in the protocol extensions. Following this, we have Add XDG Alignment Protocol for window placement control. This ultimately got closed by Matthias. In this case, it does away with the global positioning system, which is one of the major complaints a lot of Wayland devs had. So what happens now is you have a master window that is anchored to a certain point on the screen, either left, right, top, bottom, or middle, and then other windows are placed relative to that position. So say you have the GIMP canvas as your master window, you might place your toolbar at x minus 50, y 0, and then another thing at x plus 100, y 50, or something like that. For an application that works a lot like GIMP, this works great, and for new applications designed specifically around this, no problem at all. But for a lot of other things, there is a lot of weird edge cases where it creates a lot more problems than it actually solves. Also, it is an absolute porting nightmare. Most applications expect to be able to place a window where they want to place it. In this case, you have to place it relative to another window, so entire placement systems have to be completely rewritten, which is not going to happen. Like, you're just going to have applications that do not work with this system. Or you're going to have toolkits that have to make these, like, weird, complex workarounds to maybe kind of make it work, and there's just going to be a lot of bug reports that nobody knows how to deal with. Now we have the third protocol, Add XDG Placement Protocol for window positioning in work areas, second version. Now, the way I like to describe this one is, let's gaslight the Wayland devs into supporting absolute or global positioning in a way where they don't realize they're being gaslit. As we go through this, you'll see what I mean. Now, he begins by explaining the prior approaches. These are really well written, and I highly recommend you read them. But we're just going to jump ahead to the new stuff. Introducing workspaces. The new protocol in this merge request introduces the concept of a workspace. Now, workspace doesn't mean these virtual desktops I can go and swap between. The dev isn't completely set on the name workspace due to this double meaning, and there's some discussion about possibly changing it. What it is, though, is a new coordinate system per client, provided by the compositor, in which it can place its windows. Client in this context just means an application. The client can only know window positions relative to the workspace the compositor has assigned to it, and a workspace can be a defined rectangle with fixed dimensions, or an infinite space without any limits. There's a reason for that. It's because of these theoretical scrolling workspaces, which I don't think actually exist, but somebody brought up as a possibility that a global positioning system is not going to work for. I think it's kind of dumb, but this actually takes that into consideration. A workspace can be reshaped by the compositor at any time, but must always include all windows of the client that were assigned to it. every client may only have one workspace and can share the workspace with trusted other processes by sharing its handle with them. That way, an external process that's contributing a window can create its window in relation to the other windows by sharing the same coordinate system. So a lot of these scientific apps are written in kind of a mess of a way. There'll be a mix of different binaries, a mix of different languages. You might have some of it written in Python, some written in Java, some in Fortran, and all of these other languages. And you just need some way for those processes to work together. It's not like, a well-designed proprietary or open source application. Most of these projects are written with very little time and shoestring budgets. Now, this is the big thing. A workspace is a per-client entity, and clients must not assume it reflects any real object like the monitor geometry. This is going to make a lot more sense with the graphical examples, and luckily, Matthias includes exactly that. So, in the simplest case, we have a single multi-window application and a single monitor. When this application is spawned, it is assigned a workspace, it is assigned an area, that being the green box we see. Now, to the application, the top left corner of the box is 0, 0, and the bottom right corner, not the bottom right corner of the monitor, but of the green box, that is considered max by max. This can be expanded to the multi-monitor case. Now we have an application with some of its windows on the left-hand monitor and another window on the right-hand monitor. Now, to the application, this green box looks like all of the space it can use. So this is 0, 0 here, and this is max, max here. Not this corner here, the corner of the right box. This makes a lot more sense when it's not taking up basically the entire screen in the multi-application case or the multi-client case. So this blue application here and this purple application here, they have different 0, 0 coordinates. So the blue application, 0, 0 is here, and for the purple application, 0, 0 is here. But they don't know that the other application doesn't think it's the same place. They just know what their coordinate system is. There are two ways you can look at this that might make my earlier comment make a bit more sense. One, these applications effectively think they have a virtual monitor. So to this application, to the blue application, this green box is the entire monitor. To this purple application, this green box is the entire monitor. To this application, this green box is the entire monitor. They don't know anything different. They just know the space that they have been given. Another way you can look at this is effectively like a mini stacking window manager inside of your already existing window manager. So whilst it is technically not a global positioning system, you get absolute coordinates, and within the space that you've defined, it's effectively a global positioning system. It's just that different applications don't agree on the definition of global. Sometimes it's here, sometimes it's here. Whilst it's not full global positioning, most applications are designed to be fairly dynamic nowadays and can work with various different monitor sizes. And if they think that this is the entire monitor, the application is going to do its best to make use of this space. But that is not the only advantage of the protocol. Multi-process GUI applications can easily cooperate in window placement across their processes. They can do this by sharing the workspace with trusted other processes, which for most things doesn't matter, but for these weird scientific applications, that's pretty big. No limitations on the window layouts applications can come up with. This was a big problem with the prior protocol. Because this was all about predefined anchor points and placing windows relative to other windows, it was fairly limiting in what you could do. What if you don't want your main window at any of the anchor points? What if you want it to be like 100 pixels from the right of the screen? With this one, you couldn't do that. Here, there is no master window. You can just place the windows anywhere in your virtual monitor space. Relatively easy to port existing applications to the new protocol from Windows, macOS, and X11. Basically, all that needs to happen is the toolkit you're using to treat the workspace as the entire space of the monitor, as opposed to the entire monitor. it doesn't really change anything else. Context for compositors. They know the explicit layout of windows a client has created, and that those windows belong together, so can decide to, for example, allow the user to move them as a cluster between virtual workspaces, or represent them as one in a tiling window manager, and potentially only expand them if selected. These applications behave really weirdly in a tiler. It doesn't matter if it's on X11 or on Wayland, but if you can treat all the applications as if they're supposed to be a part of a single tile, you can probably make that work a little bit better. Obviously, it's going to behave weirdly on a desktop with multiple tiles, but on a completely blank desktop, rather than trying to individually tile each of the windows, you can make it work like it should be working. And clients have a better idea about the usable space available to them and might make much better placement decisions than on X11. So on X11, there is no distinction between the global positioning system and the positioning that you want to be using. So you probably have things like a dock or a status bar or things like that, which you don't want applications to be covering. Or maybe you do. But there's no way to make that distinction. Right now, it's just, hey, I can place on everything, and you gotta just move it if you don't want it to be there. Now, there are some disadvantages. The protocol is a lot more complex now, and the compositor will have to juggle more coordinate systems. So now, rather than just having the global system that was going to be used in the background anyway, now you have this mini global virtual thingy, plus the ability to, like, transfer the ownership of a workspace between different clients, and honestly, this is a lot more complex than just doing the X11 thing. If the user moves a window outside of the compositor's selected workspace bounds, the compositor needs to adapt the workspace size, so the client does not receive invalid window locations, and so the workspace still encompasses all the client's windows. This means every single window in the workspace changes its position from the client's point of view. If the window is moved out of the left or top side of the workspace, which is a bit messy, but applications should be able to handle this as they already have to deal with similar cases on X11. So basically it's saying, if you drag a window out of the workspace has to change its size, and by changing the workspace size, it changes the coordinate system being used in the workspace. So if you change where 0, 0 is, then to the application, all the window positions have just completely changed. But because you can already just change the resolution of your monitor, any sensible application should already be dealing with this. Within a workspace, the compositor still does not have a lot of context of what the windows actually do, but I do not think there is a viable, scalable solution to convey that information. To be fair, that's not really a downgrade. That's just the way it's always worked anyway, so it just doesn't make this any better. Now, maybe it's because it's the holiday season, but I've not seen anybody freak out about this. Really, I've not seen that much discussion in the first place. Now, this only has been out for about a week or so, but considering the prior protocols, usually that means, hey, let's just freak out about every little bit of positioning. But no, most of the discussion here has been fairly tame. We have some discussion here about maybe let's use a different name instead of workspace, like positioning context, positioning scope, positioning canvas. Doesn't really matter what the name is, just pick a name. Anything besides workspace probably is better. I like positioning scope, positioning context, but is the least of the concerns. Now, we do have one dev here from System 76. I feel like this protocol is just ext placement, that being the original protocol, without being bound to outputs and with the possibility of explicit sharing with other processors. Both of these are definitely an improvement, but it means this protocol still has the same issues regarding absolute positioning. A tiling window manager can't really make use of any of this, and floating window managers can only reduce the area for free placement, but might as well just give the client the full output space to place itself. So instead of doing the virtual space that's smaller than the entire screen, just give it the entire screen, which is uninteresting to me and not something Cosmic would want to support. Whilst I'm certainly interested in the idea of using a single tile to represent an entire application, even though it's using multiple windows, if that is not interesting to you, I don't think any sort of placement protocol is going to be a big benefit to a tiler. Tilers are just going to naturally be a weird way of operating. I think tilers are a better computing experience, but Windows is not tiling. macOS is not tiling. Most desktops are not tiling. Applications are not designed around tiling. And that's just the way it is. If you want applications to be able to place properly, right now until someone comes up with a better idea to do tiling, your only option is to float those windows. I don't have a better option myself, so that's what I end up doing. Now, another dev by the name of Rick Jorgensen also had some comments and some possible improvements. So, one workspace per client. Let's imagine we have two 1080p monitors with the primary on the left. An app that has a main cluster of windows that takes 1920 by 1080 pixels, and some auxiliary tools that take 580 by 1080. So it creates a workspace that is 2500 by 1080 pixels. Okay, the compositor knows it needs to straddle both monitors, but it tries to put most of the workspace on the primary monitor. This works out fine because the app author put the auxiliary tools on the right side of the workspace. But now the user reconfigures their desktop so the right screen is the primary screen. Now when the compositor tries to put most of the workspace on the primary monitor, it straddles the workspace in a poor place. If this was just two workspaces, the compositor would be able to pick intelligent places for them, regardless of a desktop configuration. Although hopefully, the compositor at least tries its best not to overlap multiple workspaces from the same client. A clever compositor might even expose a way to move the workspaces to the end user. I do think that would add a lot more complexity into porting an application, but most apps probably would just blindly make use of a single cluster with the option of having multiple clusters there for applications that want to do that extra work. So maybe it wouldn't make it any harder, it would just be a little bit harder for the compositors and the toolkits to implement. Would it be better to just expect clients to resize their workspace themselves? Now, I do know what's going to happen if you let clients do that. They're just going to say, I want the entire monitor, and just have a global positioning system because that's what they expect to see. If the Wayland devs are happy to see that happen, more power to you. But I can see them wanting to limit that for some reason. Resizing workspaces automatically. I kind of view these workspaces as transparent parent windows that the end user can break out of. To that end, rather than resizing the workspace, it would be logical if the client could only request positions within the workspace they asked for, but the compositor could return values outside of the workspace, including negative values. That way we don't have to have surprise resizes that change a bunch of coordinates without moving anything, and if the client wants, it could just resize its workspace. So, sort of using the workspace there as like a relative placement window, but not a strict, okay, you can only place within the workspace. But then you're kind of defeating the point of having the workspace there. The workspace should be all of the area that you're allowed to place in, like the same way that the entire monitor is the place that you're allowed to place in on something like X11. And of course, there is always this vague idea of security. I could imagine this getting messy from a security standpoint. Admittedly, on X, it's possible for different clients to coordinate window positions, but that's pretty niche, no? And because we're talking Wayland, there is this vague security issue. I could imagine this getting messy from a security standpoint. Admittedly, on X, it's possible for different clients to coordinate window positions, but that's pretty niche, no? As with a lot of these discussions about Wayland and security, oftentimes there isn't even an example of what the problem really could be. Like with this one, the only windows that can reposition other windows are windows that application trusts to reposition their windows. So, if it's given trust to something that's malicious, like, that's a whole nother problem outside of just Wayland that window positioning is going to be the least your concerns for. But, as with other Wayland protocols, I am very curious to see where this goes, because usually the stuff gets like a couple of months of discussion and then just vanishes into the ether. Matthias is going really hard trying to get this problem solved. I hope it gets solved. I don't know if we're going to end up using this protocol here. We're not going to use the second one. Very, very unlikely. Maybe, honestly, we'll just go back to the first one and just do what X11 was doing. We'll have like 5, 6 other protocols after this, and then eventually we decide, hey, maybe, it's a good idea that circles are round. Maybe we don't need a new shape, and doing this is fine. I could easily see KDE implementing this, WRoots implementing this, and we're just basically in the same situation that we're in with things like DRM leasing, where it works everywhere that's not GNOME, so just don't use GNOME. But that's just my thought, and maybe this time will be different. Let me know your thoughts in the comment section down below. Do you want this problem to be solved? Do you even use a multi-window application, or do you just not care whatsoever? I would love to know. So if you liked the video, go like the video. And if you really liked the video and you want to become one of these amazing people over here, check out the Patreon, subscribe, Pay, link in the description down below. That's going to be it for me, and how long to protocol number 4?
Like this.